Hello everyone, myself Yadagiri, Assistant Professor, Department of Electrical and Electronics Engineering, MLR Institute of Technology, Hyderabad, and the Faculty of Basic Electrical Engineering. So in the last class, in our last session, we have discussed about the types of elements. So in that, we have completed already the resistor and also the inductor. So now the left more element in the types of elements in the electrical circuit, that is the capacitor. So the last class we have discussed about the resistor, inductor. Then we need to discuss about right now the capacitor. So capacitor nothing but two different parallel conducting plates or materials. So can be separated by dielectric material or insulating material. So that's simply called as capacitor. So capacitor possesses the property of capacitance, and it is an energy storage element which can store energy in the form of electrostatic field. And the capacitor doesn't allow the sudden changes in the voltage. If you need to make the sudden changes towards the capacitor, it should simply behave like a short circuit path. Means it doesn't store any kind of energy. So that's why it doesn't accept or doesn't allow the sudden change in the voltage. So now coming to the voltage and the current flows of the capacitor place that we need to determine. So according to the Ohm's law, the charge flow of capacitor is directly proportional to the applied voltage. So based on the applied voltage only, so at any instant of time, so the capacitor plates should develop the charge. So that Q directly proportional to V. So then Q equal to, we need to write C into V. So this is give it as expression number 1. And you need to differentiate the equation number 1 with respect to T. So differentiate the above equation with respect to T. So then we will get dq upon dt, which equal to C into dV by dt. Then the dq upon dt, we can simply call it as current flows to the capacitor, that is I equal to C into dV by dt. So this much amount of current flows to the capacitor plates due to the applied voltage. So this is a capacitor. So capacitor means it's a two different parallel conducting plates or materials, can be dielectric material or insulating material, is simply called as capacitor. So the best example of the dielectric material is air. So air can be separated by the two different parallel or conducting plates or materials. So then simply it is called as capacitor. And capacitor obeys the capacitor acquired the property of capacitance, and it is an energy storage element which can store energy in the form of electrostatic field. And capacitor doesn't allow the sudden change in the voltage. So if you need to provide or make the sudden changes towards the capacitor voltage, then it will simply behave like a simply short circuit path. So this is the current flows to the capacitor, means the current taken by the capacitor plate should be I equal to C into dV by dt. So based on this one, we need to find out how much voltage taken by. So this is the current value. So I equal to C into dV by dt. So from this one, so we need to find out how much voltage consumed by the parallel plates, capacitor plates. So further we need to do some cross multiplication here. So finally C into dV equal to, so I into dt we got, and dV equal to I by C into dt we got. So this we need to give it as equation number 2. So integrate the equation number 2, integrating the equation number 2, so on both sides. We need to integrate the above equation on both sides. We will get integral dV equal to, so I by C, integral I by C into dt. So V equal to, we will get 1 by C integral I into dt. So this is the voltage taken by the capacitor, means the applied voltage given to the capacitor, then this much amount of voltage appear across the capacitor plates, that is simply Vc equal to 1 by C integral I into dt. So this is the voltage across the capacitor. So based on this one, need to find out the power consumed by capacitor plates. So power consumed by capacitor plates. So that is a capacitor. Plates are simply capacitor. So that is a P equal to, the formula is V into I. We can take it from electrical power. So the applied voltage is a V value. We can take see, it is key capacities only, the I value. So we can take I into, I value V C into dV upon dt. So therefore the power taken by the capacitor should be equal to, so V into C into, so dV upon dt. So we have clearly conclude this capacitor is a energy storage element, so which can store energy in the form of electrostatic field. So based on that, how much energy stored by the capacitor we need to find from this analysis. So energy stored by capacitor. So that is capital E equal to, we need to do the integration P into dt equal to the energy formula. So we have already determined the power value, so that that is, so we need to substitute that V into C into, so dV upon dt, so into dt we got, so both dt gets cancelled. So finally the energy taken by the capacitor we got, so that is a C into integral V dV we got finally. So after finishing up this differentiation, this integration, that is a C into V square by 2 we got. So the energy stored by the capacitor plate should be equal to half CV square. So this much energy taken by the capacitor. So this is the power taken by the capacitor, is a P equal to V into C into dV by dt. This is the energy consumed by or stored by the capacitor plate, that is half CV square. So this is the fundamental elements in the electrical circuit, that is a capacitor. So till now we have discussed about the fundamentals elements in the electrical circuits, that is a resistor, inductor, capacitor. So based on this one, so the resistor and inductors are, the resistor, inductors and also the capacitors are, so energy consumed elements. So from this one, so the resistor is a energy dissipated element. Resistor is a energy dissipated element which can dissipate the energy in the form of heat. So other one, that is a inductor. Inductor is a energy storage element which can store energy in the form of electromagnetic field, and the main property of inductor, it doesn't allow the sudden changes in the current. So what about capacitor? Capacitor is also one of the energy storage element in the electrical circuits, so that can store energy in the form of electrostatic field. So based on this one, so the inductor and as well as capacitors are the energy storage element. So apart from these, one more element, that is a resistor, is a energy dissipated element. So this is the end of the discussion. So this is the energy consumed elements in the electrical circuits. So thank you.